Hello everybody, how's it going? So today we're going to solve another LeetCode question. Today we're going to solve a tree question. So someone in Reddit requested that I solve a bunch of tree questions, and that's what I'm going to be doing for the next, I guess, couple of days. I just want to say, if you do have requests on what kinds of questions I should solve, what topics of like coding interviews you want me to solve, just like send me a DM on Instagram, or I'd say hit me up on Reddit. I'm pretty active on the LeetCode subreddit. I do post my videos on there, so just send me a DM on there on Instagram, or even email me. I think my email is on this channel, so let me know what type of questions you want me to solve, and I'll solve them. So this question is called binary tree right side view. So what this question wants you to do is to display in a list, or like just return a list of the elements of the binary tree that you see on the right side view. So what they mean by that is, imagine you were standing here. Let's say this is you, and then you were looking at this binary tree. They want you to return all the nodes that you see on the right side view. So that would be the nodes that go this way. So that would be something like this node, and this node. I mean, on face value, when you look at this question, it seems like a really easy question. You can just hit the root of the tree, and then you do dot right, and then you can just return 1, 3, 4. That's good. That's actually a good point. But for this example, that's going to work. But what if you were given a binary tree like this? What if you were given this binary tree? Now, when you're given this binary tree, then the answer changes to like 1, 3, and 5. That's the nodes that you see on the right side of the tree. So you just can't do you just can't traverse the right branch of the root node and expect to get the answer. So let's say, for example, we do that. Let's say we traverse the right branch of the root node and go to all its right children. So we hit 1, and then we do dot right. So that should give us something like 1. And then we also do dot right. That should give us 3. And then we do another dot right. That should give us null. So we're going to return the nodes 1, 3, and null. Those are the numbers that we're going to return. But like the actual answer would be 1, 3, and 5. So now that you're here, because it's a binary tree, going by the initial approach, you can't go back up and then get to 2 and then get to 5. You know, it's really messy. So except you have to like keep track of like the depth of nodes that you've gone through so that you can go back up and count those depths and then go back down. It's really messy. So what this question essentially is just a level order traversal of the binary tree, and then you just return the very last node of every level, because the rightmost node is going to be the last node of every level. Just return the rightmost node of every level. So the first level is 1, rightmost node is 1. Second level is level with 2 and 3, rightmost node is 3. Third level is 5, rightmost node is 5. So we're just going to do a level order traversal on the binary tree and then return the rightmost node at each level. So that's it. That's how you solve this question. So when we do that, we're going to hit 1, and then we return 1. Well, we add 1 to a list. So we're going to have a list with like 1, and then we hit 2, 3, we add 3 to the list. We're going to have another list with 3, and then we hit 5. We add 5 to the list. We're going to have another list with 5, and then we just return those 3 values, and that's the final answer. So what's the time and space complexity of this algorithm? Well, for time complexity, we're going through level by level every single node of the tree, so that would be O of n. So time is O of n. And then for space complexity, I mean, it's a little complex. Well, not really, because you have to store a list of the answers that you're going to return, right? You also, because you're doing level order traversal, you have to keep track of a queue. So that's going to be dependent on which one's larger. So I think for the right side view list that you're going to return, it's going to be dependent on the depth of the binary tree. So you can't have more elements in there than how deep the binary tree is. And then for the queue that you're going to use to store the levels, that's also going to be dependent on the longest level, the level with the most amount of children on that level. So I'd say in the worst case of, let's say, like a full binary tree with all the nodes having 2 children nodes except for like the leaf nodes, The last level, that's a level with the leaf nodes, is going to be larger than the depth of the binary tree actually. So you're going to store more nodes in the queue for the longest level than you're going to store a list of right side elements that's dependent on the depth. So let me show you an example. Take for example this binary tree. It has a depth of 1, 2, 3, 4. That's as many elements as you're going to have in like the list of right side view. And then the last level has 1, 2, 3, 4, 5, 6. There's another one hidden like on this path. So you're going to have at most 6 elements in the queue at one point, and you're only going to have at most 4 elements in the list of right side view. So I would say with a high degree of certainty that space complexity would be O of L, where L is the length of the largest level, the longest level. So that's it. That's how you like solve this question. Let's dive into the code. Alrighty, so the first thing we're going to do is make a list that's going to hold the elements in the right side view. So that would be a list of integer. Let's just call it answer. That's going to be a new array list. And then we're just going to have like a quick error check for an edge case. So if the root is null, we don't want to bother checking other stuff. So if it's ever null, we just return answer. And we want to do a level order traversal. So we have an array queue. We put a tree node in it, and then we call it queue. New array queue. And then we're going to add the root node to it for the first level. So queue.add root. And then we're going to iterate through the queue. So while not queue, that is empty, and so we like still have elements in it, we want to process those elements. So we have like a list of levels. So I'm going to say integer, and it's going to be this level. I think I have solved something like this before. I remember solving like a tree question, not like a variant of this question, maybe like binary tree level order traversal or something. And then we have a size. That's going to be the size of the queue at this point. So that should be queue.size. And then we're just going to iterate through like all the elements in the queue at this point, and then pop them out and add their children to the queue. So and I is equal to 0, I is less than size, no, I plus plus. Let's make sure we close this. And then we just make a new tree node. That would be queue.pull. That's getting stuff out of the queue. And then we just do this level that add node.value. We're just going to add this node's children to the queue. So we say if node.left is not equal to null, then we are going to add its left child to the queue, and then we do the same thing for right if it's not equal to null. And we're going to add its right child to the queue, and then after we do that, we're just going to do we're just going to grab like the last value in this level, like in this array list. That's the rightmost value in this array list. So that should be answer.add this level dot get this level dot size -1. So yeah, that should do it. That should add the rightmost value of this level to the answer. And let's not forget to add the left and right children of this node to the queue. So that would be queue.offer. So this would be node.left. And then we also offer queue.offer node.right. That should do it. And then we return answer at the end of this guy. Now let's run this and see what happens. Wrong answer. Let me see what we're doing wrong. Oh yeah, I see what's happening. So we're adding the rightmost node of this level when we're not done processing this level yet. So we should take this out of here And after we're done processing this level in this for loop, and then we can add it to the answer array list. Let's run this again. Cool, accepted, submit. And yeah, so that's how you solve this question, guys. If you like this type of content, please consider subscribing to the channel, comment down below if you have something to say, and smash the like button for the YouTube algorithm. Share this video around, and I'll see you in the next one. Bye bye.